Yeah, let's talk about these F-scoops because you've been doing some more research.
All right. So there's a great video that the Race MotoGP YouTube channel did. If you haven't seen it, go look it up. They did a good job.
And if you are a member of Patreon, I found some really great graphics that I shared on our Patreon account that really illustrates what they're doing and how the elbow goes in with some illustrations that you can see, but only on Patreon.
There you go. So effectively what's going on is they've got the little ducts on the front bodywork, kind of between the hoops of the wing. There's a little oval shaped ducts on the bottom side of the fairing. Those ducts channel air into the fairing. And then if you, on the sides of the fairing internally, there's a channel that comes back. And then on the backside edge of the fairing. So basically, if you think about the rider, when they tuck down underneath the bubble and their chin's on the gas tank and their butt's all the way back in the seat, their forearm basically presses down against this oval shaped opening and it seals it. So their forearm kind of acts like the cap over it. So when they're riding normally, braking or turning or whatever, these pathways are open. So the air from that inlet, presumably, passes straight through that ductwork and out the side of the bike. But when they're going down the front straight and they're tucked, their forearms seal off this panel and then the air is redirected elsewhere on the bike.
Elsewhere. We should just say elsewhere.
We should say elsewhere because I don't know where exactly.
Well, nobody really knows.
It's all covered.
We're all making assumptions.
So there's several theories on this. The first one and the one that the Race MotoGP, they talk about, the way that these lower side pods work on the bike and the way that these shapes on the body panels work, they're kind of like flared out toward the bottom end. So as the bike leans toward the ground, it basically acts like a diffuser on a car where it creates a high velocity underneath, which speeds up the air and creates a low pressure, and it kind of sucks the bike down to the asphalt. So as they're leaned over, it's kind of the bodywork is pulling the bike into the asphalt to create more grip for the bike so they can corner faster. But the problem is when you're going down the front straight, you still have the side pods on there, and now they're creating a lot of drag on the bike. So one of the theories is when they seal off these little plates, the way that the air is diverted basically stalls out the airflow for those side pods and for some of the other wings and channels that would normally create a lot of drag. It then minimizes the drag to help them on the front straight. So that's one idea, and that's a very plausible one, but I can't prove it, and I don't think
nobody can
going to.
That's why we're talking about it, right?
The other idea is, do these little channels, when their hands are off of it, is it literally just channeling air straight through, potentially helping the rider get a little bit of airflow so they're cooler, but basically just letting air pass by? And then when they seal them, does it force the air somehow through the hot components of the bike and then out the back and leverage the Meredith effect?
This is what I think. I really think it's Meredith effect. Aprilia 2 or 3 years ago came out really openly that in an interview, we are experimenting with Meredith effect.
Yep.
And it's one of the few physics rules that I am completely fascinated with. When I met Pierre Terreblanche a couple of years ago, I was like, are you playing with Meredith effect? And we became instant best buddies.
So probably the most famous instance of Meredith effect you can find is on a P-51 Mustang. But basically the idea is if I take cool air, pass it through radiators or some other part of the...
Superheat the air.
Yeah, if you superheat the air, so you're basically heating it up, it expands greatly. Well, that expansion on the backside of wherever the cold air is, as it expands, it creates a thrust and pushes the airplane or the motorcycle, which now practically is an airplane, forward and creates a forward thrust on the vehicle. So the idea is if they're capping off these little channels for the airflow, is it instead forcing the air through something, either through the radiator or some other heating channel that they've got underneath the skin that we'll never see, where it's basically superheating the air, and as it exhausts out the back, it's creating such a high pressure that it's actually adding or generating more thrust for the vehicle. If it's not generating some thrust, because in my mind, that almost seems difficult to create enough pressure in that short of a distance of the bodywork
to make a difference. Think how long a P-51 is compared to how long a motorcycle is.
Right? An aircraft engine is long.
And how fast a motorcycle or an airplane is going compared to a motorcycle.
So in order to create a meaningful amount of thrust on just a motorcycle, 5-6 feet long at most, sounds pretty tricky. But is it creating enough of a high pressure behind it that it's aerodynamics, it's filling in some sort of void? Because we talked about this previously. If you look at aerodynamics, typically the most aerodynamic shape, we all think of like Buck Rogers' super pointy noses. And that matters at supersonic speeds. But typically, if you're subsonic, what really matters is almost like a teardrop shape. So the front's fairly like bull-nosed, but then the way you seal the air back up after the vehicle or after the, whatever it is that's passing through it, it's very long, tapered, slow, kind of teardrop shaped until you kind of seal the air back up again around it. I could see them doing something with this high pressure where it's basically supporting the idea of the air passing past the bike and
closing
past
the negative
rider,
pressure.
Yeah, and helping it close up more smoothly so there's less drag down the front straight. I think that would make more sense than a legitimate Meredith effect of creating thrust.
The article I remember reading about this, and I wish I could find it again. You actually told me about it eons ago.
I think they filed a patent, if I remember reading.
Right, and I think they were saying like 3% thrust or something like that is what they were claiming. 5% thrust.
And if that's true, that's phenomenal.
Like 3% would be enough to counteract the turbulence from those lower things, right? Even if it's just creating, a balance point. It's possible it could be doing both.
Yeah.
Right? Like, it's such a clever idea. The thing is, we're going to see this on every bike in the future. They're all going to see if they can figure it out.
Some of these things that you see on MotoGP will never translate to your street bike.
Well,
right?
And do you need it? Do I need 3% thrust?
Well,
but as I get on the freeway?
ride height device? No. Do I need 300 horsepower? No. Like, there's certain things that happen at MotoGP levels that it's like, cool, that's the limits of what's available. But I don't need it. I'm never going to use it anyway. Like, do I need carbon brakes?
Right.
No.
And arguably, we're excited a lot of this stuff is going away because it doesn't relate, and I don't know if it makes the racing better.
But what I will say is aerodynamics matter for everybody, right? If Aprilia is developing this base and this level of knowledge and understanding of aerodynamics on a vehicle where the rider moves around and the bike leans and the bike brakes and all these different dynamic things that happen, that knowledge would translate to a touring bike. It would translate to a sport bike and a street bike. And if you're on the performance end of the scale, all of that aerodynamic stuff that helps pull the bike to the asphalt and helps all that stuff on the next version of the RSV4 would make it a better bike for a sport rider, right?